It's July 16th. Just finished work a little earlier. So it's late. I'm not really in the best mood. We thought it's gonna be like this, and indeed it is this. So yesterday was pretty simple, and this one isn't that the same? Oh, it's not the same. It's a K. So that means we need to find the ones with remainders, right? Remainders. So essentially, we want the sum to have the same remainders. What's the property if you have the same remainder? The property is I don't know, if A plus B maybe there's some modulo stuff here, but I don't remember. So essentially we say A plus B mod K, right? We can say MK plus P, and B plus C equals NK plus P. Actually, because they're the same, I should just use R. I think R is better to understand, right? What are the properties between these? This is just like the regular case, right? MN, just some stuff. Well, what we have is A plus B minus C is equal to M minus N times K. So this means A minus C mod K is equal to 0. Right? That's essentially what we have yesterday. Yesterday this is a 2. So we say either alternating, which means the skip, they are the same in parity. Right, so when you do that, they'll divide by 2. So this one is the same. Essentially, we're saying we'll have a skip need to be divisible by the K. And that happens to all the skips, right? All the skips. So let's say we have N0, N1, N2, all the way to N. Right, and you pick some out. Actually, this is not a good way to do this. Let's call it the subsequence, S0, S1 to SM. Right, so these are the subsequence. So what we're saying is the difference between these two, right? The difference between these two, right? The difference between these two, like just keep moving on. Their difference has to be divisible by K. By K. So if A minus C is divided by K and C minus D, now already C minus C, I have A, B, C, D, E, right? And say A minus C is, I'll call it MK, B minus D, NK, C minus E, PK, right? What does this tell us? Well, B and D are skipped, so AC will never interact with B and D, right? So it's skipped. So essentially, you're still finding one list of numbers So if A minus C is this, so we can say A equal to C plus MK, right? And we do this, we can say, we add this part and this part, we can say A is equal to E plus, M plus PK, right? And A will equal to C, E, E, C, D, E, F, G. Next one will be G plus something times K. Right, so they just keep going on, which means if I pick an A, right, if I pick an A, then the next one has to be a plus minus, it doesn't really matter, right? It doesn't really matter. It can be A plus something K or A minus something K, right? That will be the next one. And then the next one will be the same. So what we can do is, if I say the first number is, let's use this as example, okay? It's like a 1, 4, 2, 3, 1, 4, okay? So what I say is, if I pick 1, right, and everybody is positive, so I want to find the closest next value that, so K is equal to 3, right? I want to find the closest next value such that their difference is divisible by 3. So the next one is 4, okay? So now I want to find the next one is divisible by 3. So I say 4, 2 is no good, 3 is no good, so that's going to be 1, and that will be 4, right? That's the one. Could there be, because when it's 2, you also have the chance of the same. We did go through 2 different options. Well, actually, this what this gives us is just hold on. On this, are we supposed to have a skip? It's this. There should be something in between, right? There shouldn't be there's something in between. Hold on, let me see it one more time. What we're saying is, yeah, A minus C is, but Or you need something in between, right? You need a B in between. I mean, B can be, if we can find one, right? So let's say I have 1 and 4. I can find anyone. I can find a 3 here. So 1 plus 3 is 4. 3 plus 4 is 7. And then they all mod 3 with the same value. I can do 2, right? I can do 1. They all work. So essentially, we find a sequence, right? We find a sequence. Once we find it, but if we need another one, then this one has to have the same thing. Like if we want to do alternating, right? Maybe we're thinking about it too like more complicated than it should be. We're starting with some value, right? And again, the question is, do we pick the first number? So we can pick it. So if we pick the first, like we say we don't pick the first number, and then we have some remaining, we say that is the largest. If that is the case, if that is the case, then longest valid subsequence. Maybe we need to DP this. So if I pick a number, okay, if I pick a number, then I can go find the first one that their difference is divisible, right? Find the first one where the difference is divisible. Then you can say, now find me the largest starting from this one, right? Starting from this one. That doesn't feel right though. think I'm just trying to see if, because we have this skipping property, right? We say sub 0 and sub 1. No, sub 2, right? Sub 0 and sub 2, or sub I minus sub I plus 2. The mod k is equal to 0. I'm still trying to see if this can be used more efficiently. So if I pick a value, okay, and then I find the first one that satisfies this, if I use something later, and then we say that give us the best, then we might as well use something earlier, then we have more chance, right? So yeah, you should find a first that satisfies this, right? And once you find the first, and then this will find its first. Okay, so now we have a link of this, right? And then you need to find the numbers in between. The numbers in between, so we start from the second one. But it's not necessarily always the second one. It could be the third one, it could be the fourth one, right? So yeah, that's the difficult part. Maybe DP, like, so it's always, you either choose it or you don't choose it, right? If I don't choose it, and just the next one to the end. If I choose the first one, right? If I choose the first one, then I can say the next is determined. Can I say that? Right? Can I say dpi is the longest size for nums I to the end? So now dpi shall equal to dpi minus 1 if nums I is not taken. Yeah. Otherwise, if nums I is taken, right, then the next available must be the first nums j such that nums j minus nums I mod k is equal to 0. I wonder if this is correct, because greedy tells us this is the best strategy. But that's not true, because once we find this, we need to find somebody in between, right? We need to find somebody in between. Yeah, I don't think this one works. Alright, that's enough thought. Let's check the hints. Hint number 1. Fixed value from the k possible values. Let it be val. Oh, that's a different idea. So we are fixing this. We're fixing the k. Not fixing k, fixing the remainder. Okay. So we have certain remainder. Then you can find the first one. Then you can find the second one. Isn't that gonna be OK times? Oh shoot! I thought it's 10 to the 5th. Okay. I misjudged the complexity of the problem. I thought it's 10 to the 6th, 10 to the 5th. I mean, this 3 looks awfully like a 5th. But in this case, 10 to the 3rd, and a k is 10 to the 3rd, then it's very obvious what the solution should be. It's sort of like a, no, it's still greedy, right? It's still greedy. So basically we'll try out all different k's. Right? I kept saying k, all different remainders, starting from 0 to 1 to 2, all the way to k minus 1. And for each one, we use greedy to find the longest subsequence. So yeah, that was actually not hard, honestly. Since len nums is 10 to the 3rd, right, at most, and a k is 10 to the 3rd at most, we can solve the problem with O and k complexity. This means we go through all k possible remainders, right? And search through nums using greedy to find the longest subsequence under each remainder. And finally, we report the largest, right? Report the largest among the longest subsequences. Yeah, so O(n) times k. We're going to start with res equal to 0 and for int r equal to 0, r is smaller than k minus 1, r plus plus, right? And then we're going to go through the whole thing. And again, I think the first one will always be included. Actually, hold on. Let me think about this one more time. Is the first one always included? We can say if the first one is not included, and then we find the largest subsequence. And yeah, why is the first one included? I don't know. I don't think the first one needs to be included. Alright? There's no rule that says the first one needs to be included. Like if the first one is, if the first one is, yeah, we have a remainder, and if the first one is included, we might have to go a long way to find the second one, right? But the second one, might be that if the first one's not included, we'll get a better one. Maybe the remainder can help us something. So this plus this mod k is equal to something. Can we say let's say it's equal to 0. Yeah, like why? No, I don't see why the first one must be included. I don't see. Alright, I think this hint alone doesn't work. Let's see the second one. Let DPI store the maximum length of a subsequence with its last element x, such that, oh, what is this? This is very different from what I was thinking. DPI stored the maximum length of a subsequence with its last element x, such that x mod k is equal to I. Maximum length of a subsequence with its last element x. Huh? What? Okay, this one doesn't help me at all. Hint number 3. Answer for a subsequence ending at index y is dp k plus val minus y mod k mod k. Alright, I don't understand. Answer for a subsequence. Let DPI store the maximum length of a subsequence with its last element x. Last element x. what is this, the maximum? I think that's the answer, right? The maximum length of a subsequence. But this dpi is the remainder between x mod k. Hold on, what's so special about the x mod k? What's so special about this x mod k? So dpi is the length, right, of the max subsequence. It's the maximum subsequence, okay, with I equal to x mod k, and x is the last element. That is so specific. The last element. So we have some, well, we can have last element be any one of these, right? Then we just say, oh, if last element is 5, then I want, so may I can be k values, right? I can be k values. So we're just saying, if the last element mod k is a certain remainder, right? If the last element mod k is this remainder, what is the largest? What is the longest subsequence? Okay. So this is the relationship. So dp y, index y, right? Index y answer for a subsequence ending at index y is well, ending at index y, I can know why mod k. Like, what the hell is this? Why mod k? Why isn't it index? So this plus val, I feel. So mod k is mod k because I do mod k to get to the remainder. So this should be computing the last element, right? This should be computing the last element. K plus val. Val is the current. Hold on. What does k plus val do? K plus val. K is a divisor, right? And val is a fixed value. I want this to be divisible. And for subsequence ending at index y, what does the last value? So I know a plus b mod k, okay, equal to r. And we say, okay, say val, and this val is set, right? And then I say I know dpi. I is just the remainder, right? So let's say b is the last value. Okay, b is the last value. So we say b mod k is equal to I. B is the last value. Okay, so how does this work with this? So a plus b mod k equal to something, and b mod k is equal to something. I think there is some modulo stuff. Right, I feel there is some modulo stuff going on here. I don't know. What's the... So basically this is what we're saying is a plus b m times k plus val, and we say b equal to n times k plus I. So let's swap it in. So we say a shall equal to mk plus val minus nk minus I. So that should be m minus n times k plus val minus I, which means a mod k shall equal to val minus I. Well, this might be negative, so shall equal to val minus I plus k mod k, right? Which means dpi, right? If I know dpi, then dp this thing, dp val minus I plus k mod k. This thing is the previous plus 1 equal to dpi. See, this is my relationship, which k plus val, I have k plus val, I have a minus, I have I, but here is y. I think this is wrong. I think it should be I. And plus 1 is equal to dpi. So to find dpi, I need to find this. And okay, so that might be the relationship. That might be the relationship. Because a is the previous number, right? So, but what do I do? How do I implement? And what to think about this? Like, this is y mod k. we're supposed b is the last value, right? B is the last value, and I can get its I, ending at B, right? And I say ending at B, then we can find out. But to find this, I need to do this. This is its previous one, right? It's previous. So ending at A, right? That's essentially what we want. It's ending at A, and ending at A mod K. A mod K is val minus this, right? So ending at A. Yeah. Essentially, it is, right? So it's dp b mod k shall equal to dp a mod k plus 1, right? Because we are finding the last two. We say a and b are the last two. But I think it makes sense. So like if I find B, right, then the A will be the same, right? Because if B is this, A plus B is this, then A mod K is equal to this thing, right? Is equal to this thing. Then all we need to do is to find the largest subsequence with the last value, right? With the last value mod K is equal to this thing, right? It was equal to this thing. So we have this. Then we just need the largest ending at this. So I need to go from front to back for everything. So like the first one, right? The first one we encounter, that doesn't really mean anything, right? Because only have one value. What's the length? The length is 1, right? So in this case, I can say dp1 is 1 so far, right? Ending at this, dp1 is 1. And next one is a 4, right? Which is also dp1. So to find dp1, I need, but that's I. Oh, so you have to go through every single possibilities, right? So you say, okay, I need to go through val, as val is the thing. So val can be 0, 1, or 2. So I say if val is 0, right? Val is 0. Then 0 minus 1 plus 3 mod 3. That's going to be 2, right? That's going to be 2. So that doesn't really make any sense, does it? Because the relationship is like if I know the previous, I now have to find a no. Yeah. So basically, yeah, dp. dpi. Right. So dpi. So it has to be dp2, right? dp2 plus 1. But we don't have a dp2. We don't have a dp2. Or what we should do is consider 2, right? We'll consider 2. Hold on, let me just remove a bunch of stuff. I think we should consider starting with 2, right? So let's say the val. Let's say val is equal to 0. Okay, val is equal to 0. Then the first variable is the first 2, right? The first variable, so which is ending right here with val is equal to 0. Actually, they don't exist, right? They don't exist because 1, 4, they don't exist. So what do we say? Because this dp is also, right, val is 0, so we need to find dp 0. Well, dp 0 basically is 0. Because we don't have a dp 0. dp 1, this is 1, dp 1, and, well, I mean, 1 plus 4 is 5, and 5, so do we say dp1 is also 0 and then dp2 is also 0? Do we do that? Everybody is 0 at the beginning because the first 2 numbers, they don't, the sum is mod is not 2, it's not 0, it's 2. So now I say go to 2. And 2, so I is 2. Right? So I is equal to 2. And val is 0. So 0 minus 2 plus 3. So that'll be dp1 plus 1. dp1 needs to be something that previously ending as something is 1, which is this, right? And with it's gonna, so that's also gonna be 0, right? So dp2 is still gonna be 0. This is dp0. So everybody's gonna be 0. Everybody is going to be 0. But doesn't that mean we are heavily dependent on the first 2? Maximum length of a subsequent with its last element. Alright, I think I need to think about it again. Let me just do this. Oh my god, how simple this is. This is ridiculous. It's too late. Copy and paste. Let's submit this one first. Delete this. Alright, it's very simple, so I don't know why it's so hard for you to come up with a solution. Anyway, I think I'll keep thinking, but I really have to eat. I haven't had my dinner yet.